Hello everyone. Today I'm excited to present our project on advanced health monitoring wearable systems. So this was my project for my final year course, wearable computing. So the motivation behind it was since modern healthcare is rapidly evolving and wearable computing is at its core, we've developed an Arduino-based health monitoring wearable that brings hospital-grade physiological tracking and remote patient monitoring into anyone's hands, making preventative healthcare more accessible and affordable. So we wanted to include some core technologies like multiple biosensors like temperature sensors, pulse oximeters, ECG sensors. All these would be connected by an Arduino microcontroller, which would act as a brain. It would coordinate sensor data, analyze it, support wireless data transfer using Bluetooth or Wi-Fi. So it would have the key features and would include vital sign tracking, accurate real-time readings for temperature, heart rate, blood oxygen, ECG, even stress levels. There would be functionality for user feedback, like results would be displayed instantly on an OLED display and via mobile app, providing feedback and alerts. Then, clinical validation. Our system's results closely match those from commercial devices, offering reliable performance even during activities like walking. So, all this data would be securely sent to cloud servers where doctors could monitor patient health remotely. ML algorithms and would analyze trends to predict health issues. Then users would receive real-time notifications and critical alerts. Emergency GPS-based tracking would ensure timely responses. So there are wide applications for these kind of fitness wearables. So they have life-changing implications, like for cardiac patients, the elderly, and those managing chronic diseases. It would reduce the need for frequent hospital visits through remote care. It would enable health access in undeserved regions. So we have made a prototype over here, simple, and you can find it on Tinkercad. I've made it on Tinkercad, and I'll add the link below. You can find it on Tinkercad. So it's just a simulation and it's just a prototype which performs basic functions of a smart health, wearable. So its four main functions are temperature and pulse monitoring. We, as you can see, there's a button one over here. So we press the button one and it, measures the body temperature. Then we hold for 10 seconds and we can see the pulse also. Then there's a BMI calculator where when we press the button 2, it prompts the user input for height and weight, instantly giving BMI and health category. Then there's feature for motion detection. When we press the button 3, it activates an ultrasonic sensor for motion or fall detection, and alerts are displayed and a buzzer sounds for safety. And then there's also a feature for medicine reminder, which is, the button 4, which allows the users to set reminders for medication time supported by audible and visual alerts. So there are a lot of challenges which include improving the sensor performance during intense activity, reducing power consumption, enhancing user privacy. So our future plans involve smarter AI-driven analysis, flexible, comfortable materials, graphene-based sensors, FDA compliance, clinical use, and so I'll show you the simulation real quick. So this is a schematic view of the circuit. This is the Arduino Uno, passive infrared, then there's the LCD, there's the ultrasonic. Yeah, these are the components. Okay, just show you the code once. So coding for Arduino Uno is actually very easy. It's just C programming. There are two functions, void setup, where we initialize the variables, basically the input pins and the output pins. We name them, we configure the structure of the, uh, you know, circuit. And then if there's an LCD, a serial monitor, anything, we initialize everything in the void setup. And in the void loop, we actually write the code of how the circuit will work. So as you can see, if digital read button 1 is high, then it calculates the body temperature. It converts the analog signals into digital signals and then displays the Celsius value of the temperature. And then it categorizes on the basis of the temperature into high, normal, like that. And then if we hold for more 10 seconds, since these are resource constrained devices, battery is limited. So instead of measuring the pulse every time you measure the body temperature, if you want to measure the pulse, then you press and hold the button for 10 seconds and automatically you measure the pulse. So it won't measure the pulse all the time, only when required. So the pulse gets calculated and then the temperature and the pulse get displayed together again. Then there's the digital, the button 2. So it prompts you. Right now, it prompts us to enter the height and weight in the serial monitor. But if it's a variable, then it would prompt on screen to enter the height and the weight, and then it'll calculate your BMI, and then it'll categorize your BMI into categories like underweight, normal, overweight, moderately overweight, severely obese. Then there's the button 3, which is for motion detection while you're sleeping. If the distance, between the whatever the variable and any other object changes, or the surroundings of the variable and the distance between them changes, then it basically, yeah, the person is moving, there's some motion detected, and there's a passive infrared sensor for it, and there's ultrasonic sensor also. So passive infrared detects the motion, ultrasonic gives you the very pretty accurate, distance between the two objects, the sensor and the object. So button 3 is used for basically sleep state scheduling. So, categorizing your sleep cycles, REM, light sleep, deep sleep, like that, based on your motion. So, and then there's a medicine reminder, the form of button 4, where you can calculate the time intervals between your successive medicines. So now I'll run the circuit and display the simulation. So Vayansh, that is me, is a health monitoring wearable. So I'll just press the button 1. Right now the temperature is set at 25, as you can see. So it's displaying, yeah, 24. So it's displaying normal temperature. And then if you press and hold the button, which I'm doing currently, then the pulse gets calculated too. Second. So I'll press the button 1 again and it'll exit. Now we can move on to the button 2, the BMI calculator. So it prompts me to enter my height. So I'll enter the height, 180 centimeter, and then it'll prompt me to enter my weight. Let's say I'm 80 kgs. So then it'll display my BMI. So it's normal, as you can see. 24 comes within the range of, yeah. 24 comes in the range of 18.5 and 25, which is the normal BMI. So now we'll exit the BMI calculator and we'll move towards the, yeah. So we go towards the motion detection. As you can see, since the human is detected, the buzzer starts sounding. Uh, as you can see here, as I change the distance, this buzzer will ring if a human is, if there's movement. As you can see the display, it's changing from human not detected to human detected, so on and so forth. Yeah, okay. So now we'll exit this and then we'll set up the medicine reminder, which will again prompt me to enter some values on screen. Let's say I want to set up a medicine reminder for 12:30 p.m. So I'll put 12, it's in a 24-hour format. Then I'll put 30, then I'll put 00. So now I'll start a countdown timer of, in seconds that your medicine is after so on and so forth time. So very, yeah. So this is a very simple, implementation of a smart health monitoring wearable. It's very easy to make, easy to understand. So, there's a potentiometer to contrast the LCD. There are a lot of components which are, not special. It's always there, so I did not dive deep into it. So, in summary, this project demonstrates how accessible, affordable, wearable technology powered by Arduino and IoT can deliver reliable, proactive healthcare. As the technology advances, systems like ours will become integral to global health. Thank you for your attention.